Good morning, everyone. My name is CH Srinath. I am from CSE department. My course title is Mathematics for Computing. Today's topic about revisiting the isoperimetric graph partitioning. Revisiting the isoperimetric graph partitioning problem. And next is introduction to graph partitioning. Graph partitioning involves dividing a graph into disjoint subsets while minimizing the cut size. It has important applications in parallel computing, network design, and data clustering. The isoperimetric graph partitioning problem focuses on balancing the partition and minimizing boundary edges. Introduction to graph partitioning. Graph partitioning involves dividing a graph into disjoint subsets while minimizing the cut size, and it has important applications in parallel computing, network design, and data clustering. The isoperimetric graph partitioning problem focuses on balancing the partition and minimizing boundary edges. And next slide is the historical background. The isoperimetric problem originates from geometric analysis, dealing with shapes of minimal boundary for a given area. Its graph theoretic adaptation emerged to address combinatorial optimizing challenges. Early studies laid the groundwork from modern algorithms and theoretical backgrounds in graph partitioning. The historical background is the isoperimetric problem originates from geometric analysis, dealing with shapes of minimal boundary for a given area. Its graph theoretic adaptation emerged to address combinatorial optimization challenges. Early studies laid the background for modern algorithms and theoretical bounds in graph partitioning. And the next slide is the formal definition of the isoperimetric graph partitioning problem. Given a graph G is equals to VE, V comma E are the V means vertices and E means edges. The goal is to partition V into subsets with minimal edge boundary. The isoperimetric number measures the bottleneck of the graph, balancing size and boundary. The problem involves optimizing the ratio of boundary edges to the volume size of the subsets. The graph is equals to V comma E. V is a vertex and E is the edges. The goal is to the partition into subsets with minimal edge boundary. The isoperimetric number measures the bottleneck of the graph, balancing size and boundary. The problem involves optimizing the ratio of boundary edges to the volume size of the subsets. And next is the key concepts of Matrix. The edge boundary of a subset is the set of edges with one endpoint inside the subset and one outside. The volume of a subset is typically its sum of node weights of or number of nodes. The isoperimetric ratio quantifies how well a subset is insulated from the rest of the graph. The key concepts of metrics are the edges boundary of a subset in the set of edges with one end point inside the subset and on one outside. The isoperimetric ratio quantifies how well a subset is insulated from the rest of the graph. The volume of a subset is typically its sum of node weights or number of nodes. And these are the key concepts of metrics. And next one is challenges in the problem. The challenges is NP hard. For general graphs, making exact solution computationally infeasible for large instances. Approximation algorithms and heuristics are often employed to find near optimal partitions, balancing the trade-off between cut size and subset volume remains a central challenge. And challenges is in the problem. The challenges is in the problem. The problem is NP hard for general graphs, making exact solution compositionally infeasible for large instances. Balancing the trade-off between cut size and subset volume remains a central challenge. Approximation algorithms are often employed to find near optimal partitions. And next slide is these are the challenges in the problem. And next is the traditional approaches. What is traditional approaches? Means spectral clustering uses eigenvectors of graph Laplacians to identify good partitions. Min-cut algorithms focus on finding the smallest edge boundary, separating the graph. Multi-level methods coercion the graph partition, then refine to improve solutions. The spectral clustering uses eigenvectors of graph Laplacians to identify good partitions. Min-cut algorithms focus on finding the smallest edge boundary, separating the graph. Multi-level methods coarsen the graph partition, then refine the improved solutions. And these are the traditional approaches. The next slide is the recent developments in theory. What is the recent developments in theory means the new bounds and approximation relations have been established for special classes for graphs. The study of isoperimetric inequalities in a graph has advanced linking combinatorics and geometry. Research Researchers explore the relationship between graph structure and the difficulty of partitioning. And the recent developments in theory is the study of isoperimetric inequalities in graphs has advanced, linking combinatorics and geometry. Researchers explore the relationship between graph structure and the difficulty of partitioning. New bounds and approximation relations have been established for special classes for graphs. And next one is next. These are the recent developments in theory. And next slide is the algorithmic innovations. What is algorithmic innovations means semi-defined definite programming relaxations offer improved approximation guarantees. Machine learning techniques are utilized for scalable, data-driven partitioning. Parallel algorithms enable handling of large-scale graphs efficiently. Semi-definite programming relaxations offer improved approximation guarantees, and the parallel algorithms enable handling of large-scale graphs efficiently. These in the machine learning techniques are utilized for scalable data-driven partitioning. These are the algorithmic innovations. And next slide is the applications in modern technology. What is the applications in modern technology means it network security partitioning helps identify vulnerabilities and protect leaks. In data science, it aids in community detection within social networks. In distributed computing, it optimizes workload distribution and communication. These are the applications in modern technology. And next step is case studies and practical examples. Partitioning large-scale social networks to detect communities. Optimizing cheap design for minimizing inter-module connections. Clustering gain expression for data biological analysis. These are the case studies and practical examples. And next slide is the future research direction. Developing algorithms that balance solution quality and computational efficiency, extending the problem to dynamic graphs with changing structures, exploring quantum computing approaches for solving complex partitioning problems. And next slide is the summary of key takeaway. The isoparametric graph partitioning problem is both theoretically rich and practically relevant. Despite computational challenges, innovative algorithms continue to improve solutions. Ongoing research aims to deepen understanding and expand applications across file. And next one is the reference. References Stanger, Spellman, and Lee. And last one is a thank you for the your attention. Thank you.